I just want to start off with a story, which I can start telling before the slides are even up, conveniently for our timing today. So a while ago, I went to the grocery store because I wanted to buy some rice pudding, which cost $3. And as I'm walking through the grocery store, I notice that the Doritos are on sale. They're down from $4 to $2, so I grab a bag. And then I bring them up to the checkout, and when I get to the checkout, the clerk says, "That'll be $5. You saved $2 today." So what's the implied I want to make a few points, right? One, what's the implied counterfactual behind "you saved $2 today"? Right? The implied counterfactual is, in the absence of the sale, you still would have bought those same two items and paid $7 for them. But I just told you that was false, right? I just told you that the entire reason I picked up the Doritos is because they're on sale. And in fact, the whole purpose of a sale is to change your purchasing behavior. So in technical terms, epidemiologists call what the clerk said, technically, it's a lie. So that's the first thing, yeah. The second point I want to make is that this anecdote works a lot better with the rice pudding and the Doritos in a state where there's legal weed. And then the third point I want to make is, what does this have to do with epidemiology, right? So a couple years ago, I was working with a graduate student of mine whose name is Liz Rogowski. Terrific. She is at University of Virginia now as an assistant professor. And we were studying, for her dissertation, she was studying the effects of antibiotics in children in India on episodes of diarrhea subsequent to antibiotic use. And in parts of India, antibiotics are available over the counter without a prescription, without necessarily any indication at all. And so there's a real concern here. And the model that epidemiologists would tend to fit by default in a situation like this, which is the model we fit first, it just related as best we could the number of antibiotics an individual had had to the number of episodes of diarrhea that individual had had. And assuming you control for your confounders, you're tempted then to interpret that as the causal effect. For example, if everyone got one additional dose of antibiotics, then we would expect on average they would experience this much additional cases of diarrhea. Or the opposite, if everyone had one fewer dose of antibiotics, then they would experience this many fewer episodes of diarrhea. The problem with that, though, is that some of these doses of antibiotics were keeping these children alive. And so if you fit this model, which implies that you can just take away antibiotics from these children, you've changed a lot of other stuff here, right? And in fact, if in that model, what's implied by that model is taking away antibiotics, you wind up with a lot of dead children. That model not only doesn't make any sense, it is in a very fundamental sense an unethical model to run, right? And so it just so happened that this was maybe one of the greatest studies I've ever heard of in the history of the world, where they had visited every one of 500 homes every 3 days for multiple years and asked parents, are your children receiving antibiotics and did they have any indication? And so we were able to identify in these data which of these antibiotic doses were indicated and which weren't. And because of that, then we could run the model. What would happen if, counter to fact, these children had not received any non-indicated antibiotics? And how much good would that do? So that difference between if we just remove antibiotics at random and what is a realistic intervention we could actually do in this population illustrates this gap, I think, between how epidemiologists too often ask questions and how I think epidemiologists should think harder about how to ask questions if we want to be relevant to implementation science and to getting things done in the world. So I'm going to talk more about this using as a motivating example, of course, pre-exposure prophylaxis. But before I do, I want to make a couple of disclosures. I want to acknowledge my funding and some, though not all, of my collaborators, and also all these mistakes are mine. I also want to disclose that, like, 2 years ago or so, I did some consulting for Sanofi Pasteur. I also want to disclose that I enjoy the music of Carly Rae Jepsen. You should know who you're dealing with here. Also, that album Emotion is, like, really good. Okay, so PrEP for HIV prevention. How does it work? How do we address this question in general? Often, if we want to learn, we will run a trial, right? And a trial for PrEP might take a bunch of different forms. It might look something like this. Take some number of people, randomize them to active PrEP or placebo, blind everybody, follow people up for some number of months, count the number of cases of incident HIV, see what happened. It would look something like this, for example. This paper, the Partners PrEP study, randomized 4,747 serodiscordant couples to 3 arms, 2 different kinds of PrEP and placebo, followed people for 36 months. And the intention to treat analysis found hazard ratios of 0.33 and 0.25. Pam Murnane, for her dissertation, did a reanalysis asking a couple of different questions in the space of what if everyone had been perfectly adherent to PrEP, and using inverse probability weights and principal stratification, and found things even further from the null, which is what you'd expect. So this is where our research often stops, right? I do this too, and I have done this many times in the past. I've reported a result I believe to be internally valid on the ratio scale, and I sort of dust my hands and walk away from it. So, but that, I don't think that's quite enough to make policy on, right? And if we want to make policy on the basis of public health impact with some attention to cost, we need to do more than dropping that hazard ratio into the literature. And so one thing to think about here is that the ITT, or the effectiveness, is sometimes informally referred to as the public health effect. That's how I was taught. That's one phrase I was taught for what the ITT is. With the idea that, well, people are not going to be perfectly adherent, and so we're incorporating some of their non-adherence. But so, you know, a lot of the rest of the talk is about thinking about, well, how do the results of the ITT, or for that matter, the as-treated analysis, actually relate to public health effects, right? Because that's our goal, I think, is to improve the public health. So I'm going to talk about 2 issues in interpreting the intention to treat analysis as the effect of a public health policy. There are many more than 2 issues, but I'm just going to talk about these 2, internal versus external validity, and exposures versus population interventions. And so internal versus external validity, a trial or a well-conducted observational study usually is going to identify an internally valid sample average causal effect. And here by sample, I mean in the study sample. But we're rarely interested in the study sample for its own sake, which is something I'm going to get into in a couple slides. But it's also very rare that we formally identify the target population. And I have yet to see a trial, I think, that formally describes in great detail what the target population is. And if the target population differs systematically from the study sample, we shouldn't expect the average causal effect in the sample to be the same as the average causal effect in the target population. And if you're trying to change things in the target population, that might really matter. And then, you know, the average causal effect in the trial, in the PrEP trial, was a comparison of risks under, well, 3, I guess, but 2 counterfactual exposure distributions. You know, what if all participants were exposed to active PrEP? What if all participants were exposed to placebo? But in reality, no one's going to be exposed to placebo, right? We're not rolling out placebo across the land. And uptake is not going to be 100%. And there are other things too that were referred to in earlier talks, things like the, I think it was Dr. Odeny who referred to the Hawthorne effect and differences in adherence, right? There's all sorts of things that might differ between the trial and the scale-up. But we want to use the results of this trial to make policy. So how do we negotiate this terrain? So in an AJPH editorial a couple of years ago, some co-authors and I argued for a framework that examines internal validity and then external validity and then population intervention or scale-up effects. We didn't include cost-effectiveness analysis and implementation or dissemination after those, but I think those are the next 2 steps. So the remainder of this talk is going to be a lot of external validity and just a little bit of population intervention estimation, just because of how this talk is focused, and also to set up the next 2 talks. There was very little formal quantitative attention paid to external validity in the modern causal inference literature until the late 2000s. I think the first mention that I am familiar with was by Hernan in 2008. Frangakis in 2009 has this passage. RCT results, he says, are useful only if we can calibrate the results to predict treatment efficacy in the target population of interest. That only is a pretty strong statement, and I know for a fact there are people in this audience who object to it, but it's an interesting perspective, especially, I think, from a trialist. Keating and Lewis had a separate paper a couple years later saying statisticians, epidemiologists, and survey researchers should work together to increase understanding of these challenges and develop improved tools to handle them. And so what is this problem? So suppose that in a randomized trial that the causal effect of treatment on the outcome is a 1-year risk difference of 10% in young women and 20% in older women. And say our study is 50% older women. You know, what if our target population is only 10% older women? You know, what if our study sample oversampled older women compared to younger women? What if it accurately sampled them? What if we want to transport to a target population that's entirely older women? We should expect different average causal effects in all 3 of those populations. And in fact, it's just a matter of weighted averaging, and you can do that very much in your head. The larger problem here, I think, especially when thinking about trials, is target populations. No causal effect is well defined unless you tell me the target population that it's in. But usually in a trial, and really just as often in an observational study, the target population is not explicitly identified. And it's left implicit. And if it's left implicit, what do we think it is? So there are 3 things that I think are most likely. One is that some people say that the target population is the study sample itself, right? We're trying to make inference in the study sample. 2 is that it's the superpopulation implied by table 1. It's like table 1 times a million. That is the population for which table 1 is a simple random sample. And we don't have a good phrase for that, but I suggest some in the footnote. Maybe also the target population is just defined by the inclusion and exclusion criteria. I don't think any of these are quite right. I will caveat that one of these may well be true in a large-scale community randomized trial or in pragmatic trials generally. Hi, Maya. Because if you're studying 500,000 people, I think it's very reasonable to say they are your target population too. But in a traditional sort of individually randomized trial, even a large one like PrEP or like the ECHO trial of hormonal contraception, which has got 7,300, a lot of people in it, it seems very unlikely to me. So, for example, the inclusion and exclusion criteria often reflect risk enrichment. Often we oversample high-risk people to increase statistical power, or we anti-enrich people who we believe have comorbidities or who we think are likely to have side effects from a drug, right? And that's often done very deliberately and for very good reasons, but that means specifically it's not a good representation of your target. The simple random supersampler, whatever we're going to call this, we rarely want to generalize only to the people who, if we'd approached them, would have consented to be in our trial, right? But that's who table 1 is. It's the people who said yes. So already you're not quite, and maybe there are situations in which you can say, yeah, but that doesn't actually matter here. And fine, good. But you have to make that assumption if you want to make it. And then what about the study sample itself? Even in a large-scale pragmatic trial, even if we only want to talk about the people who we're actually studying, we want to talk about them at a future time. So very technically, your study sample is not exactly the same as your target population, although it's very close and probably not a big deal. But also, trials usually involve risks. And the way IRBs approve them is usually in terms of the generalized knowledge that you're going to generate. This is quoting from the BU IRB website. Generalizable knowledge means that the purpose or intent of the project is to test or develop scientific theories or hypotheses, to draw conclusions that are intended to be applicable beyond the populations or situations being studied. And so in most cases, you have explicitly told the IRB that your study sample is not your target population. And in fact, you have an affirmative duty to check on whether your results are generalizable. I think it's interesting that this is an ethical matter as well as, I think, a methodological one. So this is how I'm thinking about external validity. In the literature currently, there is a distinction made between two different types of external validity problems, generalizability and transportability. By generalizability, people generally mean that the study sample is a proper subset of the target population. I'm interested in the target population of California, and so I do a study among a select group of Californians, right? Then I have a problem of generalizability. But if I want to apply the results of that study to North Carolina, that's transportability. There is quite a few differences in the literature between how these two types of external validity are dealt with. I personally believe that we can unify them in a fairly straightforward way, but I haven't even come close to putting that work into peer review yet, so we won't talk about it. So let's ask then, for our example, why might the internally valid estimate of the effect of PrEP differ from the effect in a target population? What if the study sample includes more people who are highly adherent to their treatment? What does this look like? Let's look at it with some causal diagrams. This is work that was derived from a commentary I wrote on Pam's paper in AJE with Dr. Jesse Edwards of UNC. So we're interested in the effect of pre-exposure prophylaxis on HIV. But the effect of pre-exposure prophylaxis versus placebo on HIV is entirely mediated by the blood concentration of the tenofovir in your bloodstream, right? There may be, if this were not a blinded and placebo-controlled trial, you could imagine other pathways, but I would argue that the way PrEP works is that it puts drug into your bloodstream. What's interesting is that once you put that mediator in, you can draw an adherence arrow into that mediator as well. And what's interesting to notice here is that there's a structural interaction, which is that if your adherence is 0, it doesn't matter which arm of the PrEP trial you're on. You're not going to have any causal effect at all. And if you're in the placebo arm, it doesn't matter what your adherence level is. You're still not going to have any effect at all. Once we've drawn this, we can now suppose that there is a health-seeking personality type. And people with a health-seeking, and by which I mean you floss every day. That's what I mean by health-seeking personality type. You floss every day and you don't smoke. Those people are probably more adherent to their drugs. They're probably the same people who take their entire course of antibiotics, too. And those people, say, are more likely to use a condom when they're having sex, and so are, for other reasons, less likely to have HIV. If we oversample those people into our randomized trial, which I think is an entirely plausible situation, that people who are health-seeking are more interested in participating in our trial, then we have what is essentially a missing data problem in this causal diagram. We have information on the people in whom S equals 1, and we want information unconditional on S. This is not terribly different than a situation in which you're missing the outcome on some group of people within your trial. And so there are, Rion Daniel has a very nice paper in 2011 explaining how to estimate causal effects using causal diagrams when you have missing data. And then Judea Pearl and Elias Barenboim and some others have also taken these approaches to talk explicitly about generalizability and transportability problems. So, in fact, these problems are very similar to the problems we face when we're doing an observational analysis and we want to make some sort of inference about a causal effect within our study sample. Instead of exchangeability for an internal sample, if you have an observational study, you need no confounding and no selection bias, and the causal inference people call that exchangeability. We have a similar kind of assumption operating for generalizability, which is that we have no uncontrolled effect measure modification, right? So the example I gave earlier, where there's a different effect in younger women and older women, if the proportions of older and younger women are different between your sample and your target, you're going to be in trouble. What this implies in turn is that the only way to guarantee external validity is randomization. Just like the only way to guarantee there's no confounding is by randomizing your treatment, The only way to guarantee exchangeability with your target population is by conducting your trial or study in a simple random sample of that target population. And you may, of course, have exchangeability. You may have results in your trial which generalize just fine to that external population. The only way to guarantee it, at least in expectation, is simple random sampling. So I'm running long, so I'm going to go quickly. How common do we think a lack of external validity is? So my first answer to this is that I don't think we know, because I don't think anyone's really looking at it in depth. And my second answer is that I think it's pretty common. First, it's reasonably common because we know that when baseline risks change, when risks change in the unexposed, we always have effect measure modification on at least one scale, right? And this is just the math. So if you have, I wish I had a laser pointer, but if you have a baseline risk of 5% and a risk in the exposed of 10%, and then you change your risk to 10%, you cannot have both the same risk difference and risk ratio in those two strata. And since I'm running short on time, I'm not going to dwell on this math, but trust me. There's where it changes. But then the other thing is that we know that all randomized trials pretty much misrepresent the baseline risk in the target population. Again, exceptions for the pragmatic trials. But typically, randomized trials oversample people at high risk of the outcome. Serodiscordant couples are exactly a way of oversampling people at high risk of the outcome. So in addition, I think that any exposure intervention which is adherence mediated is going to lack external validity if adherence is different between the study and the target. Okay, so and then there's stuff like this. Like we have this long history of papers which actually go in and look at trials and see how different the trial populations are from the people who are actually having the events that we're interested in. Trial enrollment of people 75 years or older was up to 9%, even though they were 37% of the cases of the thing being studied. And the same thing is true of women, and the same thing is much more true of pregnant women, who are basically completely unrepresented, even though they're always part of your target population. So I'm just going to speed through the rest of this. Analytic approaches can deal with this pretty straightforwardly if you have the right information measured. And I wanted to call out what Iran was saying earlier about the demographic and health surveys. Demographic and health surveys are potentially target populations, right? There's data there that you could use these quantitative methods that Steve Cole and some others have described to take your trial and see what would happen had we conducted it in this other population. And that's never going to be perfect for all sorts of reasons, but it's going to be better than not doing it at all. And so I'm just going to leave it here, and if you want to talk to me about population intervention effects later, we can totally talk about that. But some future directions of this work are, in particular, that we can build traditional randomized trials which consider questions of external validity from the first day, right? That is a thing that we can build into trial designs, and if that's a thing that's interesting to you, please come talk to me about it, because I would love to talk to you about it.